Welcome to the Foundry by Forge College. In our last session, we spent some time hunting down risks in Solana deployments. Today, we're shifting gears back to our applied Solidity development track. We've mapped out some great pricing models on spreadsheets, but a spreadsheet is just a plan. It relies on a human being to look at the numbers and follow the rules, which means it isn't quite secure enough for a true automated token sale. To fix that, we use a smart contract. Think of this smart contract as a fully automated digital vending machine. Just like a physical vending machine, you put money in, the machine checks its internal, pre-programmed rules, and it gives you exactly what you paid for. No human intervention, no calculator mistakes. Translating your pricing model into this code is how you turn economic theory into a real, functioning digital sale. Before we can let anyone use our digital vending machine, we must stock it and set the rules. In the blockchain programs here at Forge College, we call these rules the machine's permanent memory, or its state variables. First, we define an owner. This is the machine's memory recording the specific digital address of the person who holds the administrative keys. Looking at this blueprint, you'll see a node for the owner key and one marked price tag. We set this price using the smallest possible crumbs of currency. Using these tiny units ensures the machine's math stays perfectly accurate down to the cent. Because we bake these settings into the code before launching, the price is locked in. Nobody can sneak in and change the price tag once the sale starts. Defining these settings is how you take your standard business rules and anchor them permanently onto the blockchain. Let's say we want to offer a bulk discount. If someone buys a large amount, the price goes down. Smart contracts have a strict limitation. They only understand whole numbers. Fractions bounce off the barrier, while whole integers pass straight through. To fix this, we use basis points. Instead of a decimal, we drop a whole number like 500 flawlessly into the equation. Trust me, you want to avoid decimals here. A tiny rounding error in a smart contract is a quick way to accidentally give away all your assets for free. Adapting standard financial math into strict whole number logic guarantees that the contract calculates the numbers with absolute precision. Next, we need a way for people to actually interact with the machine. We build a buy function. This acts as the machine's coin slot. It accepts the payment and applies that bulk discount we just set up. But here is the twist. Our minimal machine doesn't actually drop a physical token into the tray. Instead, it prints out a permanent digital receipt. In our code, we bundle this info together in a struct, which is just a fancy way of saying a digital index card that keeps the buyer's address, their payment, and their tokens organized in one place. The buy function and this digital index card system work hand in hand. Every single transaction gets locked into a record that cannot be tampered with. You might be wondering, why bother printing a receipt? Why not just send the tokens straight to the buyer's wallet right then and there? By separating the pricing math from the actual delivery of the assets, we keep the contract incredibly simple. Simple code is easy to secure and much faster for experts to check for errors. What we end up with is a flawless, error-free list of buyers, and that list is the exact bridge we need to cross into the next phase. In our next lesson, Participant Onboarding and Sale Flow, we will take that exact buyer list and use it to handle whitelisting, identity checks, and the final distribution of those tokens. By keeping the logic precise and the rules strict, smart contracts allow you to map real-world economics into code that performs exactly as it's programmed, every single time. If you're ready to explore more Web3 courses and join our learning community, it's easy to get started. Just visit forge.college to find all the resources you need. See you next time.